Here's the next example. Y double dot minus 3y dot minus 2y equal to u dot minus u. So basically in this mathematical equation, if I write it down, y over u, it's going to be s minus 1 over s square minus 3s minus 2. That's a mathematical equation or transfer function basically. Okay, so similar to the previous example, what we're going to do, we're going to write it down, y double dot equal to so here y double dot equal to u dot minus u plus 3y dot plus 2y. Okay, now I'm integrating it to both sides twice. So if I integrate it twice, y equal to integral of u, because the dot and one integral cancel out, minus double integral of u plus 3 integral of y plus 2 times double integral of y. Now I'm going to write down or draw the simulation diagram. So remember, there are two integrals, so there are two boxes. That is our y, here is our u. Okay, now to reach y, u has to pass through one integral. Okay, so to reach y, u has to pass through one integral. That's good. And then u has to pass through two integrals, but it is negative. So let me do this. So here is u. So u has to pass through two integrals, so that is minus, so I have minus, plus 3y has to pass through one integral, y has to pass through one integral through 3, so there is a 3 here. Okay, and then it has to pass through two integrals, but it has 2, a constant 2. So this is complete simulation diagram. Now I have x1 dot, x2 dot. Okay, now I'm going to write down the state equation, output equation. X1 dot equal to, so 3x1 plus x2 plus u, and x2 dot equal to 2x1 minus u. Okay, so and these are the state equations, and output equation is y equal to x1. This is my output equation. Okay, now if I write it down in matrix format, a equal to 3 1 2 0, and b equal to 1 minus 1, and c equal to 1 0, d equal to 0. So these are the state and output equation by using observable canonical form. Now I'm going to start with another example. So here is another mathematical equation. So it's a third order system, y triple dot minus 6y double dot minus 2y equal to u double dot plus 2u dot minus 3u. Here he's asking us to find the state equation, output equation by using observable canonical form. So similar, I'm going to write it down, y triple dot equal to u double dot plus 2u dot minus 3u plus 6y double dot plus 2y. Okay, so integrate it 3 times because it's a third order system. Y equal to so there are 2 dots, so they get cancel out, so integral of u plus 2 times double integral of u minus 3 times triple integral of u plus 6 times integral of y plus 2 times triple integral of y. Okay, so that's our mathematical equation. Now since you see 3 state variables or basically 3 integrals, so I'm going to have 3 integrals. Here is my y and u. So to get y, u has to pass through one integral, So to get y, u has to pass through one integral, and u has to pass through two integrals, but at the same time through a constant 2. Okay, and it has to pass through -3. So here is 3, that must be negative. Okay, and y has to pass through one integral, y has to pass through one integral, but there is a constant 6, and y has to pass through three integrals with a constant 2. Okay, this is a complete simulation diagram. Now I'm going to draw the state, define the state variable x1 dot, x2 dot, x3 dot. Okay, now x1 dot equal to 6x1 plus x2 plus u, and x2 dot equal to x3 plus 2u, x3 dot equal to 2x1 minus 3u. Okay, these are the state equations, and output equation y equal to x1. Okay, so these are the state equations, these are the output equation. Okay, so based on this I can write down the A matrix. A equal to 6 1 0 0 0 1 2 0 0, and B equal to 1 2 minus 3, and C equal to 1 0 0, D equal to 0. Okay, so this is our mathematical, or this is the state equation, output equation for the given mathematical model by using observable canonical form. I'm going to solve one more example in this video. So here is the next example. Here y double dot minus 6y dot minus 2y equal to u double dot plus 2u dot minus 3u. So in this example we have number of poles equal to number of zeros. It is very rare cases you see this. Most probably the system kind of I mean, whenever you see number of poles equal to number of zeros, that means the input and output, they have direct connection. So whenever I change the input, immediately output is going to changes. So in the previous cases that's not the case. So here there is no direct connection between the input and output. Okay, so whatever I make that changes in the input, it has to go through certain process, then you will see the change in the output. Okay, but here what happens there, whenever I change the input, immediately you will see change in the output. So it's a direct connection between the input and output. I would say this is kind of emergency system. It's just like you're pushing emergency button. Once you push the emergency button, the system has to stop. So that kind of system. So as usual, I'm going to write it down. Y double dot equal to u double dot plus 2u dot minus 3u plus 6y dot plus 2y. Integrate it twice, so y equal to u plus 2 integral of u minus 3 double integral of u plus 6 integral of y plus 2 double integral of y. Okay, now I'm going to draw the simulation diagram. Since there are two integrals, so draw the two integrals. Here is my y, here is my u. So to get y equal to u, so there is a direct relation right there. So here y is directly proportional to u, so here is my u. Okay, plus 2 integral of, u is passing through one integral, but multiplied by constant 2. Okay, and minus 3, so here is minus 3 Okay, and 6 y is passing through one integral, but multiplied by 6, that's positive, and it has to pass through two integrals multiplied by 2. Here is my simulation diagram. Okay, now here is x1 dot, x2 dot. Okay, so what is x1 dot? X1 dot equal to I have 6y. Okay, I have 6y plus x2 plus 2u. Okay, I shouldn't have y in the x1 dot, so I have to replace that. I will do that in a second. And x2 dot equal to 2y minus 3u. Okay, and at the same time, these are the state equations, but at the same time I need to replace y. Y equal to, can I say, x1 plus u. Okay, y equal to x1 plus u. So now I'm going to substitute this y in here at the same time in here. So my x1 dot equal to 6x1 plus x2, 6u plus 2u, which is 8u, and x2 dot equal to 2x1 plus 2u minus 3u, which is minus u. Okay, so I have a equal to 6 1 2 0, and b equal to 8 minus 1, c equal to 1 0, and d equal to 1. So whenever you see D matrix, that means there is a direct relation between input and output. That's what the D matrix indicates. Okay, thank you. I'll stop it here. In the next video I'll start with the new model. Thank you.